To do the confidence intervals for the mean, you have to go through a decision-making process first. And that is really dependent on if you know what the standard deviation of the population is. Alright, standard deviation of the population is sigma. So let's shortcut this into two things. Yes, we know it. No, we don't. So, do I know sigma? Yes or no? Now, if it's a yes, this is what we call a z-interval. And if it's no, this is what we call a t-interval. Okay, so for the z-interval, we're going to read, or for most things, we're going to read table F. And this one is also table F, but slightly differently. Let's see how to read table F then. Now, we're doing confidence intervals. That's the top row here. We'll get to these two in Chapter 8. And so these are the most typical ones they do in the problems. There may be an exception, which then we would have to go to Table E and do the inverse normal thing, is look up the area and find it. But most of the problems in the book will use these, and so it's not a big deal. And so this is where we start. So in each one of these problems, we'll be given a confidence level. Okay, so our confidence level, say, is 90% for our example. Now the next thing is, if I do know the standard deviation, then that means it's a z-table. And if you read down the sign here all the way to the bottom, this is a z. Okay, so anything for z's are along the bottom. So you go to the 90%, or whatever your confidence is, for example, 90%, and then read all the way to the bottom and look up the value here, and you see that it's 1.645. So our z would be 1.645. That's the cutoff. In other words, what they're doing is they're telling you this spot, minus 1.645, plus 1.645, and this area is 90% of it is in the middle right there. Okay, so we're finding those two values. Okay, now for the other one, we need to do what's called a t interval. So for a t, we still use the same thing, the same table I mean, and our confidence level, for example, let's keep it at 90%. But now there's a new number we need. It's called the degrees of freedom, and that's the sample size minus 1. So if we suppose that our sample size was 24, then our degrees of freedom would be 24 minus 1, or 23. Okay, so if you look at our table, up on the side it says DF, or degrees of freedom. So we go to 90, slide our finger down to 23, and go over, and we get 1.714. So that would be our T, 1.714, like that. Okay, and so on this T table, which is essentially normal looking, this is minus 1.714, and this is plus 1.714, and 90% is in the middle, just like the standard normal that we get the other one from. Alright,